Morning, guys. It's me again, Stefano, and today we will be learning about chemistry. Today we will be learning about a branch of chemistry, which is electrochemistry. Right. So, without further ado, let me screen share my presentation. So, what is electrochemistry? First, right? Electrochemistry is a branch of chemistry which deals with the study of the relationship between the chemical reaction and electricity, like its name, electro, which is electricity, and chemistry, which is described as a chemical reaction. Now we are going to deep dive, but to understand this more, we can see here that there is substance A and there is substance B. So this substance A has a flow of electrons, which gives electrons to substance B. And this describes as the electricity and chemical reaction. Now, to understand this more, we are going to discuss the chemical reaction and also the oxidation state, right? To explain the oxidation state, there are 10 rules and we need to follow them. So first, an element itself or a free element has a net charge of 0. So for example, the oxygen gas, which is an element by itself, which is a free element, has a net charge of 0. It is the same like in nitrogen gas. The nitrogen gas is an element by itself, so it is a free element. Thus, it also has a net charge of 0. Moving on to the second rule. Element in family 1A is always +1, except for hydrogen. Example, in sodium chloride or NaCl. The charge of Na is always +1. Another example is potassium bromide or KBr. The charge of K is also always +1. There are other elements too in the family 1A. For example, lithium, sodium, potassium, rubidium, calcium, and francium. So all of these elements is +1. Now, moving on to the third rule. Element in family 2A is always +2. This rule has the same concept like the rule just now that I have mentioned. But this one, it is describing the element in family 2A. So element in family 2A is always +2. For example, calcium oxide or CaO. The charge of calcium in here is always +2. Another example is barium sulfide. For example, barium sulfide, the charge of BAS, the charge of BA is also always +2. Now, there are also other elements in family 2A. For example, beryllium, magnesium, calcium, strontium, barium, and radium. So all of these elements has a net charge of +2, right? Now, there is something that you're noticing, right? All of the neutral compound that I have mentioned earlier in the previous example, for example, like sodium chloride, potassium bromide, calcium oxide, barium sulfide, they all have the sum of the oxidation number of them is 0 because they are a natural compound, and this is the fourth rule. To describe this more, for example, in sodium chloride, right? We all know that the charge of Na is +1 because it belongs to the family 1A. So the charge of chloride is -1. Why? Because the natural compound must be 0. So +1 and -1 resulting in 0. It is the same like in barium sulfide, for example. The charge of barium is +2. Then because it's belong to the family 2A, right? So the charge of sulfur, to make it 0, must be -2. But how about the ions, the polyatomic ions that has the ion charge, right? So the sum of the oxidation number for a polyatomic ion is equal to the ion charge. what does this mean, right? So for example, in sulfate ion, sulfate ion has an ion charge of -2. So we all know that the sum of the oxidation number for the sulfate ion is -2 because it has the ion charge of -2. So SO4 equals to -2, where oxygen has the net charge of -2. And we are asked to find the charge of sulfur. Now we can change sulfur into X right here, right? So X is equals to, there are 4 oxygens, so 4 times -2. So X equals to -2, we move here, plus 8. So X is equals to plus 6. This is pretty simple because you need to search for the ion charge. Then after you know the ion charge, you can find what is the question asked for, right? There are also other examples for polyatomic ion. For example, we already mentioned sulfate ion. We have like phosphorus ion and many other polyatomic ion like in here. You can read it by yourself, right? Next, the charge of a monoatomic ion is the charge itself. So what does this mean? The charge of, for example, the lithium ion. Lithium ion is a monoatomic ion and it has the ion charge of +1, right? So lithium ion, the sum of the oxidation number is also +1 because it has the ion charge of 1. Now, moving on, hydrogen becomes +1 with non-metals and become -1 with metals. So in calcium hydride, we all know that calcium is metal and it belongs to the family A. So calcium has net charge of positive. So to make this neutral compound to 0 according to the rule just now, we need H2 to become -2. And by according to this rule, it is okay for H2 to become negative because it is made of metal. So -1 times 2 it is equals to -2. And notice that the rules correlate with each other, right? Then hydrogen becomes +1 with non-metals. So you'll know that nitrogen is a non-metals, which has a net charge of -3. To make this neutral compound 0, we need H3 to become +3, right? So +1 times 3 equals to +3. So +3 and -3 is 0. Next, halogens are usually -1, but become positive with oxygen except for fluorine. So to prove that halogens are usually -1, for example, we have magnesium chloride. Mg belongs to the family 2A, like we have mentioned earlier just now. So this has the net charge of +2. So Cl2 must be -2, right, to make the neutral compound 0. So -1 times 2 is -2. Other halogens like fluorine, bromine, iodine, acetylene, adenosine, fluorine is usually -1. But there are exceptions to this, right? Fluorine is always -1, and this is the net. The last rule is oxygen usually -2, but it became -1 in peroxide. For example, in aluminum oxide, so Al has the charge of +3. So +3 times 2 is +6. To make this neutral compound 0, we need -6. So -6 divided by 3 is -2, right? So oxygen is usually -2, right? In this example. But in a peroxide, this is H2O2, sorry. In a peroxide, this is H2O2. It becomes -1. So H2 is +1 times 2 is -2. But normally this is -2. So this element is not 0, right? This is not a neutral compound. But in a peroxide, the oxygen becomes -1. So H2 is plus 2 and O2 is plus negative 2. So this also is a neutral compound. Now, after we learned the oxidation state and we also already learned the oxidation number, we can move on to the chemical reaction, which is called the redox reaction, right? So first, what is a redox reaction? A redox reaction is a reaction in which these electrons of an atom in a substance transferred to an atom of another substance or the same substance. Like in the previous example in the first slide that I have mentioned earlier, that the electrons, the electricity will move from one substance to another substance. This is called the redox reaction. This is the chemical reaction in electrochemistry. And we have two types of redox reaction: the oxidation reaction and also the reduction reaction. So the oxidation reaction, right? Oxidation reaction is a half reaction that involves less of electrons. Usually oxidation reaction correlates with reducing agent. So a reducing agent is a substance that carries the atom that has lost electrons. We are going to explain this more, and we are going to also learn some acronyms. The second types of redox reaction is reduction reaction. So reduction reaction is a half reaction that involves the gain of electron. So oxidation, there are loss of electron, and in reduction reaction, we have gain of electrons. The oxidation agent is a substance that carries the atom that has gained electrons. So notice that the oxidation agent is correlated also with the reduction reaction, right? Now, there are three types of redox as gain or loss of hydrogen. Is the first redox. Now, to deep dive into this chemical reaction, we need to learn some acronym to make the process of learning easier. First, we have LoRa and GOROA. What is GROA and LoRa? So loss of hydrogen is oxidation. The substance called reducing agent. Notice that oxidation reaction correlates with reducing agent. So loss of hydrogen is oxidation. There is substance called reducing agent. Now, GROA is gain of hydrogen is reduction. The substance called oxidizing agent. Reduction, oxidizing agent. Oxidation, reducing agent. Now, for example, redox as gain or loss of hydrogen is, we have this hydrogen sulfide plus chlorine gas equals to sulfur plus hydrochloric acid, right? So you can see that hydrogen sulfide turns into only sulfur. This is the loss of hydrogen in this chemical reaction, right? We see that the loss of hydrogen resulting into oxidation. Then the loss of hydrogen, we can see that the reducing agent is H2S. Notice that oxidation correlates with reducing agent. So H2S is the reducing agent because it lost hydrogen. Next, we can see that this chlorine gas gains hydrogen, right? Therefore, this is a reduction. Because it gains hydrogen, the oxidizing agent is chlorine. This is the first redox as gain or loss of hydrogen. This is the first step, and this is the first type. Moving on to the second type, which is redox as gain or loss of oxygen. Now, this is the same like the first acronym, which is LoRa and GROA, but this time it is loss of oxygen is reduction. The substance called is oxidizing agent. it is the same, but the difference is just oxygen, right? Just now it is hydrogen, and now it is oxygen. So gain of oxygen is oxidation. The substance called is reducing agent. The example for this is aluminium plus copper oxide equals to aluminum oxide plus copper. You can see that this aluminium gains some oxygen right here, right? So this aluminium gains some oxygen. And following this acronym right here, gain of oxygen, that's oxidation. So you gain some oxygen. So therefore, this process is oxidation. Now, what does oxidation correlates with? Yes, that's right, reducing agent, right? So the reducing agent in here is aluminum. Then we see that there is a loss of oxygen to the copper oxide, right? The copper oxide lost some oxygen, so therefore this process is called reduction. Because there is some reduction here, what does it correlates with? Yes, the oxidizing agent. So this process of reduction resulting that CuO or copper oxide is the oxidizing agent. The last type of the redox reaction is redox as gain or loss of electrons. So loss of, it is the same like just now, but this time it is loss of electron is reduction. The substance called is oxidation agent. Goora, gain of electron, is oxidation. The substance called is reducing agent. So oxidation correlates with reducing agent, and reduction correlates with oxidation agent. To understand further, we have another example. Right, so for example here, hydrogen sulfide. Hydrogen sulfide, to make this neutral compound, we need to assign the electrons. The electrons is +1, -2, Cl, because this is a free element. According to the rule just now that we have mentioned earlier, this is 0, right? This is 0. Sulfur is also 0 because it is also a free element. And hydrogen is +1 and chlorine is -1, right? Because the rule that halogen is usually -1. And you can see that this sulfur lost some electrons. What does this mean? So from -2, the sulfur becomes 0, right? So it lost some electrons. Therefore, this process is called oxidation. But how about the gain of electrons? You can see that Cl here is 0, but it gains some electrons, so it becomes -1. This process is called reduction. And the reducing agent is H2S because it lost some electrons. The oxidizing agent here is Cl chlorine gas because it gains some electron, right? Therefore, thank you. This is the lessons that I'm sharing today. I hope we will meet soon again. Thank you very much.